Let's start discussing about the transfer function of analog low pass filter approximated through Butterworth approximation. For understanding this, it is essential to know about the magnitude squared function of a normalized Butterworth filter. Before that, the magnitude transfer function of a Butterworth filter is represented by modulus of h of j omega, which is equal to 1 divided by 1 plus j, or let me put it in this way, it will become 1 plus in general 1 plus omega by omega c power 2n whole power 1 by 2. N denotes order of the Butterworth filter. It is an integer whose values will be greater than or equal to 1, 1, 2, 3, etc. The omega c stands for cutoff frequency of the Butterworth filter. So the function is assumed to be monotonically decreasing, where the maximum response is obtained at omega is equal to 0 only. So when you start increasing the order of the filter, when order increases for values of omega less than omega c, the Butterworth approximation tends to imitate the characteristics of ideal low pass filter. Ideal low pass filter. This happens at omega is equal to 0. So let's start working towards the derivation of magnitude transfer function of an ideal low pass filter or practical low pass filter using Butterworth approximation. As you all know, this is equal to 1 divided by 1 plus omega by omega c power 2n. This denominator polynomial is within the square root. So when you square on both the sides, you will find out that this will become squared magnitude response, which will be equal to 1 divided by 1 plus omega by omega c power 2n. For various values of n may be greater than or equal to 1, n is equal to 1, 2, 3, etc. It goes on and on. So let's substitute the omega c value as 1 radians per second, assuming that the filter is a normalized Butterworth filter, low pass filter, whose cutoff frequency is equal to 1 radians per second. So as you all know, this expression will become h of j omega, the whole squared magnitude response will become, it will get reduced to 1 plus sigma power 2n. Right? Agreed. Next. At this situation, if I start imagining the replacement for s, which will be equal to sigma plus j omega, assuming sigma is equal to 0, definitely s is equal to j omega. So omega becomes simply s by j. When we start substituting into the squared magnitude transfer function of a practical filter or a low pass filter through Butterworth approximation, it is naturally, for a normalized case, it is omega power 2n. When omega is replaced, it will become 1 divided by 1 plus s by j whole power 2n. Agreed. But you know one thing, this can be written as you all know, h of j omega the whole square will become h of j omega multiplied by h of minus j omega, or I can say h of s into h of minus s. So this h of s into h of minus s, which will be equal to 1 divided by 1 plus s by sigma power 2n, right? Or I can even convert this using complex conjugate method, and this will be finally rewritten as 1 plus minus 1 power n instead of minus j squared, so multiplied by s power 2n. Agreed. So this can be written as, because as you all know, j squared can be written as minus 1. So this is finally written as h of s into h of j omega into h of minus j omega becomes 1 plus minus 1 power n into s power 2n. So this can be written as h of s into h of minus s can be written as 1 divided by 1 plus minus s squared power n. So this relationship can be viewed as a product of two transfer functions. which has got different poles. For example, the poles of this h of s transfer function will lie on the left hand side of s plane. Whereas the poles of this h, if you imagine that h of s is a stable system and whose poles are assumed to be present on the left hand side of the s plane, obviously for h of minus s you need to think in the opposite direction. So automatically the poles are assumed to be present in the right hand side part of s plane. The presence of two factors h of s and h of minus s will obviously lead to these two different thought processes. And if h of s has got roots in the left half, roots of this h of s are assumed to be present on the left hand side of the s plane, obviously the system is said to be a stable system. So let me take this to find out the roots. Let me take the denominator polynomial minus s power s squared whole power n can be written as, or to find out the roots, I can simply take the denominator polynomial 1 plus minus s squared power n is equal to 0. So for values of n odd number, odd order filter, this s power 2n will get, or this term for n odd 1 plus minus of s squared whole power n will get reduced to s power 2n, which will be equal to 1 only. Can you just imagine? Because this is 1 plus minus s squared power n, which is equal to 0. So minus s squared power n becomes minus 1. When n is an odd number, as you all know, when n is an odd number, what will happen? This, sorry. When n is an odd number, this number will become minus s squared, which is equal to minus 1. So s squared will become plus 1. For an example, I just say that it is an odd number and it is equal to 1. If n is equal to 1, odd number. Can you just imagine? So in general, for values of n odd, s power 2n will become simply equal to 1 only. So let me get into the solution of this problem. S power 2n is equal to 1, which is equal to e power j 2 pi, or let me say e power j 2 pi k. So I can find out the poles now. Sk is equal to, it will become e power j 2 pi k by n only, where values of k is equal to 1, 2, 3, because it is an odd order filter. For various values of k, I can say these many number of poles will be generated. For n even, can you just imagine 1 plus minus s squared whole power n is equal to 0. So this expression will get reduced to 1 plus minus s squared, because n is an even number. Let me imagine that n is equal to 2, simplest case. So this becomes is equal to 0. So this will become s power 4, which is equal to 0. Can you just imagine? That's what I say. If n is equal to 2, this equation, sorry, minus s squared power squared will be equal to minus 1, and this will be s power 4, which is equal to minus 1. Or in general, for only values of even, in general, I can say s power 2n is equal to minus 1 only. Minus 1 is possible only with e power j 2k minus 1 pi. So let us introduce these two conditions. For values of n odd, sk becomes e power j 2 pi k divided by capital N. For values of n even, this sk becomes e power j 2k minus 1 pi divided by 2n. So these are all true for various values of k, 1, 2, 3, n, 2n. So you can just find out, even for this case, if s is equal to 3, sorry, if order is equal to 3, this becomes simply s power, or n is equal to 3, isn't it? So you can find out that this s power 2n is equal to 1 only. So it is equal to 1, which is possible with e power if n is equal to 3, I can say sk is equal to e power j 2k minus 1 pi divided by 2n, 2 into n is equal to 3. So for values of k is equal to 1, 2, 3, you can notice that s power 6 is equal to 1 only.